Welcome to the next installment of my video lecture series. And in this particular lecture series, I'm going to be looking at a Cournot duopoly and going through the process of finding the equilibrium output for each firm and the equilibrium price in the marketplace. So you might see a problem like this, or very similar to this. Duopoly quantity setting firms face the market demand curve P equals 280 minus Q. Each firm has a marginal cost of $40 per unit. What is the Cournot equilibrium? So there's the inverse demand function, and the thing that you need to realize that with a duopoly, there are only two firms producing, so Q is going to be equal to the output of both firms, Q sub 1 and Q sub 2. So we can insert Q sub 1 plus Q sub 2 in place of Q here. So that's just showing us that the entire output is being produced by these two firms. So we know this is a duopoly, and these two firms are going to be producing the entire output. Now, if we're concerned about the reaction functions, that's what we're going to be doing, is getting the reaction functions here. One of the things we need to know is what is the total revenue. So if we want to, for example, take a look at firm 1, we would take the price and multiply by the quantity produced by firm 1. So that will give us our total revenue function. So here we have total revenue for firm 1. The portion in the brackets here is just price. We just move that down to calculate total revenue. So in the brackets we have price, and we're just multiplying by Q because we know that price times quantity is total revenue. And if we have price and we multiply it by the quantity of firm 1, then we are going to have the total revenue of firm 1. So we're going to multiply that through. So we have Q1 multiplied by 280, so we have 280 Q1. So we are taking Q1 and multiplying it by negative Q sub 1. So that gives us Q sub 1 squared. And we're multiplying Q sub 1 with negative Q sub 2. There's a negative sign out in front here. So that gives us negative Q sub 2 Q1. So now we have the total revenue function for the firm. Now we're going to have to subtract off our total cost to give us the profit function. So the profit function of firm 1 is equal to that. This left-hand portion here is just total revenue. And on the right, we have our total cost. We were told that marginal revenue is equal to 40. So 40 times Q1 will give us the total cost of firm 1. And the left-hand side here is the total revenue of firm 1. Our next step is going to be taking the first derivative of the profit function of firm 1 with respect to Q1. And that will give us 280 minus 2Q sub 1 minus Q sub 2 minus 40. And just to go over this briefly, I have already posted a video on how to take a derivative, but I'll go through this again just in case you're still having some troubles doing that. And remember, what we do here is that we're taking the derivative of profit with respect to Q1. So what we do is we take the exponent and multiply it in the front, and then we take that exponent and subtract 1. So we don't put that this is to the first power. That's just dropped off. So what we're doing here is we're multiplying by 1, and Q sub 1 to the 0 power now is equal to 1. So we have 1 times 280 multiplied by 1, which gives us 280. We do the same thing here. We take the exponent and multiply it in the front. So that gives us 2Q1, and we subtract 1 off of the exponent, which gives us Q1 to the first power. So we have Q2 multiplied by Q sub 1 to the first power. And you do the same going through here. So that gives us 280 minus 2Q sub 1 minus Q sub 2 minus 40. And now we set that equal to 0 and solve for Q2. So we add 2Q sub 1 to both sides after we set the first derivative equal to 0. So we have 2Q sub 1 is equal to 240 minus Q sub 2. We divide both sides by 2, and we get Q sub 1 is equal to 120 minus 0.5 Q2. So that is the reaction function of firm 1. Now, given the fact that we have the same marginal cost and we don't have differentiated demand curves, that is what the reaction function of firm 2 is going to look like. So make sure you remember that. If you'd like, you can go through the steps, all those laborious steps that I went through to find the reaction function of firm 1 and do the same thing for Q2. But given the fact that the marginal costs are the same and we don't have differentiated demand curves, we're going to get, I don't want to say the same reaction function. We just substitute out wherever we see Q1, we put Q2 in its place, and wherever we see Q2, we put Q1 in its place. I guess you could say that they are symmetrical with respect to that. So now that we have this, all we need to do is to substitute in the value of what Q2 is equal to into the function, the reaction function that we have for Q1. So we know that Q sub 2 is equal to 120 minus 0.5 Q1. We could substitute that into Q2, which we are doing right there. So all we did was substitute that into what Q2 was equal to into the reaction function for firm 1. So if we multiply that 0.5, that negative 0.5 all the way through, we get 120 minus 60. All right, so we have negative 0.5 multiplied by 120, which gives us negative 60. And we have the negative 0.5, multiply that by negative 0.5 Q1, which gives us positive 0.25 Q1. We simplify, we have 120 minus 60, so Q1 is going to be equal to 60 plus 0.25 Q1. We can subtract 0.25 Q1 from both sides, and that gives us 0.75 Q1 is equal to 60. And then if we divide both sides by 0.75, we get Q1 is equal to 80. And since these are symmetrical, the reaction functions are symmetrical, we get Q sub 2 is also equal to 80. So we have the quantities for each one, and we remember what the inverse demand function looked like. It looked exactly like that. It was 280 minus Q sub 1 plus Q sub 2. We insert Q1 and Q2 into that inverse demand function. So we have 280 minus 160, and we get a price of 120.